Are you there? It's me again. Today I've got a 2020 GMC Acadia with a 3.6 liter engine. It's coming to me with some history. It just came from a couple other shops that have already made a repair attempt. I'll go over the service history here. Let's see, we've got shop visit from August of 2024. Verified customer's concern of check engine light, accessed the diagnostic report, and performed a scan to find current codes P0498. Further examination found the evaporative emission canister vent solenoid is out of specifications. Recommend replacement of evaporative emission canister vent solenoid to start. No part replacement or repairs were made at this time. Okay, so it was diagnosed at the first shop back in August. Second shop, P0498. Where's the diagnostic notes? Current. Proceeded to research the code first, inspected the canister vent valve, and it is not holding vacuum like it should. Recommend replacing that to start. We replaced the canister vent valve and the code still will not clear. We do not have a lot of repair information on this code. Customer will need to take vehicle to a GM dealer for further inspection. So it sounds like shop number 2 actually performed some sort of repair. They replaced the valve based on a mechanical failure that it wouldn't hold vacuum. Although a P0498 vent valve control solenoid circuit low voltage, says right there low voltage, probably would not be caused by a mechanical failure. Quick code scan, and ECM P0498 has returned. Current failed in this ignition, so I guess we're going to move on with the circuit test. Most likely this should be a fairly simple diagnostic, but we'll see what happens. Okay, we're using 1990s technology here on this channel. It's just an actual real piece of paper. Look at that. I can feel it. I can crumple it up. I can write on it if I wanted to. Evap vent solenoid. It's a simple circuit. One wire for power, one wire for ground. Ground is controlled through the fuel pump driver control module. We've got a vent solenoid control circuit low code. So most likely what that means is that in the off state, meaning the vent valve is not being operated, not being closed, the fuel pump driver control module would expect to see a high voltage of battery voltage through this fuse when the circuit's off. So does that mean that we've got a blown fuse, an open circuit somewhere in between, or high resistance? Don't know yet, but like I said, it should be fairly simple. What would I do? I would go to the vent solenoid first, verify that I have full battery voltage on terminal 2, the red wire from that fuse. I may even want to check the fuse before I even raise it up in the air. Fuse block rear body, that should be fairly easy to get to and check. And then I would verify if I have any excessive resistance or voltage drop on this circuit when it's commanded on. So with the scanner, I could probably command it on and test for excessive voltage drop on this circuit and determine which direction I'll go. Is the problem on the ground side or is it on the power side? First off, let me find out if the ECM has any useful data. Why am I talking to the ECM? Well, because the fuel pump driver control module does not have the capability of speaking to the scanner, so I can't actually request any information from that module, but I have to go through everything through the ECM. Evap vent control low voltage test status malfunction. So already right here, key on and engine not running. We haven't even started up the engine. We've already got a malfunction status on the circuit. So I would suspect, do we have a blown fuse? Do we have a completely open wire? Let's find out. I'm gonna have to raise it up and take a look. I've opted to go for the vent valve first because the rear body fuse block unfortunately requires a lot of disassembly and it's impossible to get to. Vent valve does appear to be new. So terminal 2 is on this side. That's the hot side. Grab my my power probe accessory here. I've got B+ here and ground here, so I can test that the test light's actually working. And do this one-handed if I can. Test light lights. Okay, so we do have power at the vent valve. Does that mean we have an open circuit from here back to the fuel pump driver control module? Interesting. Okay, so we do have power here. That would mean that the problem is on the ground side. I did some research. X409 is in the driver's side wheel well, and I'd have to remove the panel to get to that. I have seen some issues with the chassis harness because of that location. Fuel pump driver control module is actually fairly easy to get to. I did actually put eyes on it, so the easiest test from here would be to test continuity from the vent valve to the fuel pump driver control module connector and check for either an open circuit or excessive resistance is what I would suspect we're going to find. Okay, fuel pump driver control module right there above the left rear axle shaft. Let me set up my light here and disconnect that connector so I can do my continuity test. So that's back there. Vent solenoid is all the way up here, so we're going to do a continuity test from there back to there. Nothing sinister going on in there. I don't see any crusties. Which terminal was I after again? Let me take a look. Alright, well, the first thing I noticed, this is terminal 21. The first thing I noticed is there's very little resistance on this terminal. It feels pretty loose. All these terminals feel pretty loose. But this one's like really loose. So that may be the problem all by itself, but we'll continue with the continuity test. Also a good idea to make sure that the ohmmeter is actually functioning. Yes, it is. So we verified our equipment before we do the test. Okay, so test from here to here. We've got 0.4, 0.5 ohms, so that's a good continuity test end to end. And then I would want to check from B plus and ground and verify there's no continuity to ground or B plus. Okay, and I conveniently have the power and ground right here. No continuity to ground. No continuity to power. So do you know what that means? It means that the loose terminal here is most likely the actual cause of the problem. Let me see if I can reposition this thing downhill. I mean, there's very little resistance going in. Yeah, it just falls right out. So I'm going to call it a spread terminal on terminal 21 of the fuel pump driver control module. If that doesn't fix it, we would have to call it a faulty module because we've proven the circuitry all the way back to this point. I could even plug in, let me refocus this, there you go. I could even plug in this connector here, and because there's B plus from the fuse, should theoretically go through the vent valve, through the wiring, and end up all the way back here. I should be able to check with my voltmeter and get a battery voltage reading with the system off. I don't know, it just kind of depends how much does the voltmeter draw, but I should get some sort of voltage back here. Okay, the meter is grounded to the transfer case there. The other end is connected to terminal 21. The display won't reach, so luckily it's removable, and I do have a battery voltage reading, just like I said I should, and that basically proves the circuitry is okay. It absolutely proves that the problem is this loose, super loose terminal here, and I should be able to fix it with a wiring repair. So I don't know that I'll have parts in stock today, but we'll see. This vehicle may have to come back, and I'll have to wait to finish my video. Alright, so I was doing a little research on this loose terminal thing, and the service information says to use this probe on terminal 21, and it fits loosely into that one, it fits loosely into all of these really. And then the adjacent terminal 22 right here, it actually calls for a different one. It calls for this one I just dropped. Okay, I dropped it, but terminal 22 adjacent calls for this probe, this test probe, and that one fits nice and tight in both of these. So, and they appear to be the same terminal. Nothing looks different. So I decided I'll take the module off and actually compare what does the module terminals actually look like. Okay, and the terminals on the module, that one right there is terminal 21 for the evap. It looks to be closer to this one. So I don't know if that's an error in the service information or something, but both of these probes are very similar. They have similar width and length, but the purple one's a little thicker. So the purple one matches up with these terminals. So I think this is the actual correct terminal. So if that's true, if this one is the correct terminal for testing terminal 21 and it is not loose, then that would imply that the fuel pump driver control module is faulty, right? Interesting. I do happen to have a known good fuel pump control module, so let me plug that in and just see what happens to our vent valve control circuit test in our scan tool. Okay, the known good fuel pump driver control module is plugged in. Let me drop this down and let's check codes and test, see what that malfunction status said. Okay, back here in the vehicle, we've got a DTC status. This ignition passed. Go over to the actual data. Low voltage test circuit is now okay. So it's a little bit of a luxury to have that module on hand already, but whatever. The diagnostics still led to the same conclusion. It led to a faulty fuel pump power control module. And we almost had a misdiagnosis as a loose spread terminal due to a service information error listing the incorrect diagnostic test probe for terminal 21, although the adjacent terminal called for something else, but all those terminals seem to be okay. So I think that's an error in the service information. I will have to submit and see if they can get that fixed if I get a chance. Looks like I know what's going to fix this one. I already demonstrated it, what it's going to take to fix it. It's going to be a fuel pump power control module. And because I happen to have one, a known good module, I plugged it in and proved that. So now I don't even have to wait for parts to finish and edit and post this video. So I guess that's it. In summary, 2020 GMC Acadia came in with a P0498 code, evap vent solenoid low circuit. It had been to 2 shops previously. The first shop diagnosed it, no repairs were performed. The second shop evidently diagnosed it as a mechanical failure and replaced the evap vent solenoid. 1 month after that visit, the vehicle's back here to come to me with the same code again, P0498. And we just did the diagnostic and came to the conclusion it's a faulty fuel pump power control module. Fun little additional trivia fact, both of those shops, when I was beginning my career, I applied for a job at both of them and neither one of them was interested, but that was 10, 15 years ago. Just a little bit of trivia. Only the real ones that watch to the end of the video get to know stuff like that, so. Well, it turns out that this fuel pump power control module is on national back order, and I wouldn't have been able to get one and show you the final result anyway. So vehicle's going out the door and I'm gonna move on. And I guess when we get parts available, we'll do a final fix. But until that point, see you later. That's all I got. Thanks. Okay, and since you're one of the real ones and you watched all the way to the end of the video, you get to see the bonus content. Here's my donor module. This is the original module. This is my brand new module. See the difference in part numbers. There's been a part number update, and ignore the orientation there. The part number's just upside down. Made in USA, that's a good sign. Or is it? I don't know these days. But I'm gonna install the new one, clear the codes, verify this all fixed, and we're done. Okay, real ones, there you have it. Super bonus premium, paid membership only content. Oh wait, we don't do that here. We've got the new part installed. I've just got to check the codes, erase the codes. I've already demonstrated what it's going to take to fix it, and I'm basically done here. So TTFN, bye. Thanks for watching. Last test pass, this ignition pass, clear codes, add all. Hit OK again, because everything's okay. Okay? Okay. Not gonna worry about that.